Okay, so we have worked on the grouping method, right? The common factor method for us to solve for cubic functions, right? What we're going to need to touch on now, right, is solving cubic functions using the factor theorem. So this is generally something you're going to learn in grade 12, right? And it's actually quite simple, right? You don't want to think of this as something that's difficult or aggressive because yeah, it is that simple. I'm not just saying that because I've been through grade 12 already. I generally believe that, right? So, anyways, with your factor theorem, key thing is this is all you need to remember. Our factor theorem basically allows us to use trial and error to find at least one solution for our equation and then use that one solution to work out the rest of the other solutions, right? So I repeat, our factor theorem basically says we should use trial and error, right, to find one solution for this equation that is equal to 0. The moment we have found that one solution, it is going to allow us to find other solutions of x, because remember we said with the cubic graph you have quite a few solutions. You sometimes have one, sometimes you have two, but you generally usually have three, right? So in our case, when we say use trial and error, you may be asking yourself, how many times are you gonna guess or try and find an answer? So the good news is for grade 12, you will usually always need to check between these numbers, right? So all you're going to do is, if you're going to use trial and error, test out positive or negative 1 and then move on to positive or negative 2 and then move on to positive or negative 3, right? If it's not one of these, literally just double check if you have written your question correctly, right? Because for grade 12, you will always have cases where you can use trial and error first to get your first solution, and then that one solution you will use it to get your other solutions. So in our case, we're going to test out negative 1 first because it's the very first number, right? So testing out if negative 1 is a solution, this is all we need to do. Where x is, we just threw a negative 1 there, and then if you solve for this equation, so this is showing us that negative 1 is definitely a solution. So what it means is, if this is to be factorized, right, one of your brackets will be x plus 1, right? Because remember, negative 1 is a solution, so it means that this is one of your brackets. Because if this is one of your brackets, that's where negative 1 is coming from, right? So because we have gotten at least one solution using trial and error that satisfies this equation, we are now able to now dig deeper, right, into using the factor theorem to solve for this cubic function and get all our other solutions. Okay, so we said with the factor theorem, it's a matter of getting one solution that satisfies the equation and then you use that one solution to get the others. Before we can do that, what you want to keep in mind is anytime we are referring to a factor theorem, what you want to keep in mind is all solutions to like cubic graphs or quadratic equations or anything like that, all solutions before the final answer, like while they're still in brackets and stuff, we usually refer to those as factors, right? So we know that with a cubic graph, you usually have 3 factors, right? And then each of them give you those 3 solutions, right? So in our case, we found out one of the factors, right? Because we know that x is equal to negative 1 is a solution, so it means x plus 1 is a factor. So for us to get our other 2 factors, what we want to keep in mind is these 2 brackets, right, will always give us a quadratic equation. So instead of us visualizing this expression as 3 brackets immediately, what you may want to do is have one of your factors, the one that you already had, right? And then these 2, just visualize them as a quadratic equation. So what I mean is, whatever this expression is, right, it is being represented by whatever this is, right? So we know that this is a factor of our main expression. So we know that it's one of our solutions, right? And then our other two brackets, we say we should just visualize them as a quadratic equation, right? So at this point, we know that things are about to get simple, right? Because all we need to do is we got one solution, right? And we represented all our other solutions as a quadratic equation. Before we get to the simple part, all you want to do is FOIL all this out. Okay, so we haven't done anything funny, right? All we have done is we have basically FOILed these two brackets out. This small one multiplied by that big one, we just FOILed, right? We know that x multiplied by each of these gives us these three terms, and then 1 multiplied by each of these gives us these three terms. And then these, all we did was we grouped together ones that look alike, ones that are like terms, right? Nothing has x to the power of 3, so this is on its own. This has x squared and that also has x squared, so we put those together. This has x, that also has x, so we put those together. And then this does not have x at all, so we just leave that on its own. So at this point, right, you are literally just a few steps closer to you having your final answer, right? So reason is we said that we want to solve for this cubic graph, and we know that the one key thing that is stopping us from solving our cubic graph is we don't know what our other solutions are going to be. So technically our task is to get a value for A, get a value for B, and then get a value for C. Because as long as we get these three values, 1, 2, 3, we will have an expression for this bracket, right? And as long as we have an expression for this bracket, we will be able to use our quadratic formula to solve for it, right? So that we get all our other solutions. So for us to show why this is simple, right? This here, right, represents what you have at the top there. Before we move on to the next step, what you may want to do is, firstly, can you see that these two have x squared, and then these two just have x on its own, and then this does not have x in it, does not have x at all, right? So what you may want to do is take out x squared as a common factor here, and then take out x as a common factor there, right? However, instead of you writing x squared in front or writing x in front, what you may actually want to do is something like this, right? So what you will note is all we've done is, right, we know that these two both have x squared, these two both have x. So we know that this is showing us that whatever this equation is, right, it is being represented by whatever it is that we have down here, right? So for us to get a value for A here, a value for B there, and a value for C there, all we need to do is to just mix and match, literally. If you check, this is showing us that there's an x to the power of 3 there, right? Here there's an x to the power of 3. So whatever the value in front of x to the power of 3, here we can see that it's a 2. So it basically shows us that A is a 2. Because we said whatever this is, it is being represented by whatever we have down here, right? We can clearly see there's an x to the power of 3 there, x to the power of 3, x squared there, x squared there, a single x there, a single x there, and then something without x at all, right? So firstly, we say we're just going to mix and match. We need a value for A, B, and C, and we're going to get A, B, and C from down here using what we have up there, right? So from the top, A here, we can clearly see that it is equal to positive 2, right? And then our next portion, we can clearly see that in front of x squared, right, we have here a negative 3, right? So we know that negative 3 is being represented by b plus a there, right? We already know what a is. A is just a 2, so we can just throw that in there and get a value for b, right? So you just continue the process, literally, right? So here we can see that in front of x, we have a negative 8, right? Here in front of our x, we have c plus b. So all that is telling us is negative 8 is equal to c plus b, right? And then we already have a value for b, that's just equal to negative 5. This is showing us that c is just equal to negative 3. We have a, we have b, we have c. If you wanted to use your last portion of your sum, you could, because I mean you can clearly see here c is just equal to negative 3. So it really doesn't matter, really, right? So we had to work out a cubic function, right, using our factor theorem. And we said what you need to do is to get one solution using trial and error that satisfies this equation. The one solution we got was that x is equal to negative 1. So because our solution is x is equal to negative 1, it means that our first bracket, if you were to factorize this, one of our brackets would be x plus 1, right? Because if x minus 1 is a solution, it means that x plus 1 was one of your brackets, right? So we have one of those solutions, and to represent our other solutions, we say just write that out as a quadratic equation. Once you have written that out, FOIL out everything. FOIL it out, right? We FOILed here, it's just distributing everything, right? Distribute everything, and then this is what we have at the end, right? And then we said anything with x squared, you put it together. Anything with x alone, you put it together. Anything without, you put it alone. Anything with x to the power 3, you put it on its own, right? And then we said all you need to do now is we need to get a value for a value for b, and a value for c, right? And for us to get a, b, and c, all you do is you just mix and match, right? Here there's a 2, meaning that a is a 2. Whatever this value is, it's going to be negative 3. Whatever this value is, it's going to be negative 8. And then we know whatever this value is just a negative 3, right, for c there. So here we know that we're not done, because this has just given us a value for a value for b, and a value for c. However, we're going to use a, b, and c, throw those in there, right? And then we will be able to finish up our factor theorem question. So remember we mentioned the factor theorem, it's just long. If we did not say that, well, yeah, it's just long, but it's simple. It's nothing too difficult, right? So let's throw those values in there and then see what we end up with. There we go, right? So we got A, we got B, and we got C. Remember, in this case, A, B, and C, they're just placeholders. So what we have now done is, this is our main expression. We have now factorized it, right? So us having this factorized, we already know that x minus 1 is one of our solutions, yes, right? However, this bracket here is going to give us our second solution, right? This is just a quadratic equation, so we can easily just use our quadratic formula to work it out. There we go, right? So x is just going to be equal to negative a half, or x is going to be equal to positive 3, or also x is just going to be equal to negative 1. So factor theorem, it's a bit lengthy, right? However, it works, right? The good news is, again, the whole trial and error portion, those values will generally always be either plus or negative 1, plus or minus negative 2, plus or minus 3. If it's not one of those, again, just maybe look at your question, see if you wrote it correctly, because in grade 12, for your factor theorem, you will always be able to get your first factor, right, using trial and error. Once you have that first factor, right, or that first solution rather, we know that we say to use that to get your other factors, right? So we have the first factor that we got here. To represent all our other answers, you just write out a quadratic equation, always, right? Once you have written that out, if you remember, we just FOILed everything out, mixed and matched, got a value for A, B, and C, and then here we're able to use our quadratic formula. If you wanted to factorize, you would have gotten something like this, right? So yeah, that's the factor theorem. It's straightforward in my opinion. The other good news is, as we said, with solving cubic functions, there are quite a few methods. And the other method that we're going to work on in another tutorial is the long division method, right? So when the time comes, I'll definitely upload that and then let you guys know.